All right, hello everyone. Welcome to another of our Infura developer community calls. We're very excited to have you guys on this one. We are celebrating a major milestone, which I'll let Trish talk about more. In the meantime, let me do a quick housekeeping around Crowdcast, which is what we're using right now for this call. As you can see on the right-hand side, we have a chat that you guys can obviously engage with us on. Trish is going to keep an eye on that chat throughout. However, if you have questions that you'd like to have answered by our speakers today and interact with the product teams, please add that to the Ask a Question queue. It's at the bottom of the screen. And that way we can have a chance to pull you up on stage if you'd like to ask in person, or I'll ask on your behalf. Also, other people can upvote that question so we can make sure that's a priority that we get that answered. For the most part, we usually get all the questions answered. We'll leave a little extra time at the end, of course, for Q&A. And then if you actually have a poll in there that you can answer, that would be great. If you guys haven't already answered that, to please go ahead and put your answer in there. That helps us get a sense of where you guys are at, and so that the speakers can kind of tailor their the content around what you guys are looking to understand. And then finally, this is going to be available as a replay at the same link after this call. There's a little shiny green button at the bottom. If you aren't already on our Discord community, please join us there. That's an invite into our Discord community where you can continue the conversation with the Infura team. So without further ado, I'll hand the microphone over to Trish. And I am Shay. Welcome, everyone.
Hi, everyone. I'm Trish, or you can call me May. I am the product marketing lead for Infura as well as DevTools. So welcome to our second developer community meetup. Today we have like a really exciting agenda for you. We have Tom Hay from our product team here to talk a little bit about our product updates. And we also have Fred Blacks, who's from Arbitrum, who's doing amazing things here as well to talk a little bit about what Arbitrum is doing. What is Arbitrum? We have Nick DeAndre from Truffle, who's from ConsenSys, to talk about a new dashboard provider for MetaMask. And if you haven't heard already in the Twitterverse, ClubNFT recently saved a ton of artists' work using IPFS, and Chris King, the co-founder, is here to talk about it. So before we go into the actual agenda, I want to extend a really huge thank you to our 350,000 developers. It's really exciting because just a year ago we were 100,000, but we've grown since 3 to 4x. And this is all thanks to all of you for wanting to create, just really amazing and innovative projects in the metaverse. So thank you so much. And we now support, not just Ethereum, but we support all of the different L2 solutions as well, like Arbitrum, Polygon, Optimism, as well as, like IPFS. So thank you so much. So I'm going to pass this off to Tom Hay, who's going to talk a little bit about just some of what's going on with Infura and all of the new things that are happening. So Tom, I'm going to pass to you. And if you could screen share, that would be great.
Thanks, May. So I just want to echo what May said is, we're so honored that, there's so many of you building on the Infura platform, and we're so honored to be a part of your journey. So it's really cool that we can play a part in your journey through Web3. I'm going to quickly go over some updates to the user experience of Infura, and I will just share my screen to give you an update on what we're calling stats, dashboards, notifications. Oh my. So we'll share real quick. Hopefully everyone can see my screen. So just going to give you a walkthrough of three updates that we've made to Infura. The first,
Tom, can you, sorry to interrupt, can you make yours main screen? I'm trying to do that and it's not shifting as a, there you go. Perfect.
I didn't do anything, so I have no clue. But just to
there you go. All good.
To jump in, we've made some updates to Infura, and so I just want to show you on if today I deployed a smart contract using Infura, just a simple storage contract, and just wanted to use that as a way to walk you through what some of the updates that we've made. So in Infura, we've changed the layout to make it as user friendly as possible. So now you can quickly go to stats, Infura transactions, the Explorer, see the add-ons that you have, your profile, all on this left side of the screen. You can also switch networks using this drop-down selector. You can see that our dashboards have changed, and we have added to our statistics some really interesting information that we hope allows you to understand how Infura is the request volumes that you're sending via Infura. So as you can see, earlier today, I deployed a smart contract. There was 1,535 requests that were sent during that deployment. And what we can, hopefully everyone can see this, but just as you see in these a little bit more built out, we can now show to you more information that can tell you about the top 5 request volumes that you're sending, your requests per network, the request activity. We think this is going to be really helpful for users to not only understand what's going on, but potentially debug any issues that they're having. Additionally, we've also launched notifications. So you've probably seen, maybe you have seen, maybe you haven't seen this email show up in your inbox with the email associated with your Infura account. But we're now sending notifications to let you know when you're at 75%, 85%, or 100% of your daily usage of Infura. We're hoping that these updates to the user experience allow you to make the best choices when it comes to using Infura. And we hope that it is something that can help you in your development of your projects, whether it's deploying those projects to testnets or to Ethereum mainnet or any of the other networks that we have. Finally, we love your feedback. And so please give us feedback on these new features, what you like about them, what you'd like to see more of, because we love to incorporate that in future releases. So thank you all. I will now, I believe, pass it over to Fred, who I'm really excited to hear from.
Thanks, Tom. Yeah, I'm going to, there you go, Fred. And I believe, Fred, you'll go ahead and share your screen as well.
Yep.
Hey, queued up.
Thank you for the great segue and presentation. Glad to be here at the Infura community call. And I'll be talking a bit more about Arbitrum, what we've done, what we have shipped, and what's coming next. And let me just share my screen a bit.
There you go.
Awesome. So, hey, I'm Fred. I'm a software engineer at OFFCHAIN Labs, and we're the team behind Arbitrum, building it out. And I'll be talking a bit today about layer 2 scaling and how we do it. So before we talk about scaling, let's talk about the first things first. What are we scaling and why do we want to scale it, right? And center of the question is Ethereum, and why do we love Ethereum? Well, for me, one of the biggest things is the security it offers, and decentralization always being a priority on the protocol development. You being able to run your own node and everything that comes along with the Ethereum protocol. And along with the Ethereum security, there's also this notion of generalized computation, right? You're able to write your smart contracts, be it in Viper or Solidity, and compile it down so it can be executed in the EVM. And since Ethereum went live, there has been just like many bear markets, many bull markets, and what we've been seeing is just a lot of adoption on this platform. There are many people using it, and many developers deploying it, and many users using these applications by the developers. But this comes with one annoying bad side, which is congestion, right? The more demand there is, the supply isn't keeping up. So transaction fees are getting higher, and this is very bad because it prices out many users from doing different things and many different use cases from actually being viable on mainnet. And that's where Arbitrum comes in. We're a scaling solution that is trying to tackle this problem of congestion and lower the transaction fees on Ethereum. And this isn't a question of what if or when we're actually going to ship. We've been live on mainnet, and we've been live for developers since second quarter this year. That's quite a few months now, and we've been open to all end users with permissionless deployment on all contracts since early September this year. And with that, what we actually shipped is an optimistic rollup that aims to scale Ethereum. That's our flagship chain right now. And since launching, we've had like a lot of value flow in. We have over $2.5 billion in locked assets, like in bridges going into Arbitrum. We've have processed over 3 million transactions, a bunch of accounts, a bunch of contracts, and a lot of execution going down. So it's been a really interesting journey and exhilarating to just be able to ship all this scaling tech and actually get adoption, users and developers actually being able to benefit from it. But there's this big question, right? That is, we've done all these things, we're improving and doing all that, but how does this work? How do we actually scale? And what I'll give here is a bit of an abstract mental model that you can use to think about this. And what's going on behind the hood is we have this virtual machine, a layer 2 virtual machine from Arbitrum. And this virtual machine is fully deterministic in its execution. So we have a set of inputs that go into this virtual machine. And these inputs can be, for example, user transactions or ETH deposits. And all these inputs get processed by this VM on the L2, and it generates an output. And for the same set of inputs, we always get the same output because this execution is deterministic. Well, we have this layer 2 virtual machine, but we wanted to inherit the security from layer 1, from Ethereum, right? There's this big question of how can we actually do this? So we have this layer 1 virtual machine, Ethereum, that is secure. We like it. It has a lot of congestion, but we want to move part of its traffic to this L2 virtual machine. And we want this L2 virtual machine to be as secure as this layer 1 virtual machine. So instead of feeding these inputs straight into the L1 virtual machine, straight into the L2 virtual machine, we actually post all this transaction data, everything the users are doing, everything that's going on the chain, we actually post it to Ethereum. But we don't actually execute it there. We just post the inputs there. And then this L2 virtual machine actually does the execution, has a deterministic output, and this output gets proven back into Ethereum. And that's the general overview of what's going down. And one big thing that I actually glossed over here that is important to mention is the sequencer. That in this almost sequence diagram, let's say, it's missing one key agent, one key participant in the protocol, which is the sequencer. And the sequencer has a superpower that it's able to order transactions. But when it's able to order transactions, it gains another really cool thing in the protocol, which is we have this notion of fast soft confirmations. And by that, what I mean is that the sequencer is able to tell users the result of their transactions very quickly, as long as you trust the sequencer. So for example, when you're interacting with Uniswap or with SushiSwap, or with any of the dApps deployed on Arbitrum, one thing that you might feel is that the UX feels very good because you make a transaction and you get an answer quickly. And the sequencer is the one who's responsible for that. And the way the flow goes around this is instead of the transactions going straight into Ethereum, these inputs go to the sequencer first. The sequencer chooses the order, and then the sequencer itself posts to Ethereum on your behalf. And if you don't want to trust the sequencer, there's always a censorship resistant route, which is you can go straight to the L1 virtual machine yourself, but there's a delay then, and you don't get to have this benefit of the fast UX and just feeling very comfortable. But yeah, the sequencer, as you might have thought, it has the superpower which can feel very dangerous. And the thing that is worth mentioning here is that the sequencer is never able to steal user funds. The only thing it can do is change the transaction ordering. And with that, it can extract an EV and just benefit off of this. But right now, we're the ones running the sequencer, and we have plans and active research around a pathway to actually decentralizing the sequencer to keep this really nice UX of fast confirmations, but not having a central entity actually running this, which we are running right now. But yeah, this was a bit of a tangent, big tangent, but bringing back, many times we talk about scaling and we're talking about rollups and just throwing this term around. And what do we actually mean when we say that we're scaling Ethereum with a rollup, right? Well, with a rollup, what we mean is the set of inputs that are going into the chain here. We're rolling up many transactions together. We're just batching them and posting everything as call data on Ethereum, but we don't actually execute it. We're making all this data available and ordered on the layer 1 Ethereum chain. And with that, we're able to always prove back the execution of this VM. And benefits we get out of this is that we get this trustless bridge, a bridge that is actually enforced by the protocol itself, that if Arbitrum is executing correctly, you're able to send a message from L1 to L2, like a transaction with a deposit, and from L2 to the L1, just relying on the protocol itself with no extra committees or any other trust assumptions. And yeah, that's the rollup side of things. And then there's the optimistic rollup, which is the flavor that we're doing. And what this refers to is actually the proving side of things and how we actually prove the execution of this layer 2 chain back into Ethereum. And the way we do this is kind of like through an optimistic execution approach, that if you're looking back to this diagram, the output section, we allow any validator to actually post the output of execution from this VM back into Ethereum. And we optimistically accept it. But there is an incentive that whenever you're posting this output, you need to post a bond alongside it. You stake a certain amount of Ether, and you say, if someone proves that the execution of my assertion is actually incorrect, you can prove it on chain against me, and you get part of my stake. And that's the approach we do. So there is a minimal footprint on the L1 side, because most of the time the incentives are that no one wants to actually post an invalid commitment on the L1 chain, because otherwise they'll just get proven that it's invalid and they'll lose their money. And the way that this proving goes is through fraud proofs. And it's kind of like an interactive game in which, let's say you executed 5 transactions, and this reduces down to a bunch of bytes code being executed. We do kind of like a binary search on chain until we narrow down to a single opcode, and then we execute that one opcode on Ethereum on the case of someone trying to prove fraud from another validator. And yeah, the cool thing about this whole setup is that you actually just need to trust a single validator in order for the whole protocol to actually function correctly. And what that means is, let's say there's a pool of like 100 different validators that are interacting on chain, and 99 of them are malicious. If there is at least one that wants the correct execution of the chain to happen, they're able to do it correctly, and the protocol progresses. But yeah, we're here in an Infura community call, and there's this big question of what's Infura doing on the Arbitrum ecosystem, and it's actually doing a lot. There has been this blog post and paper by, I believe, Patrick McCory at Infura that has some really interesting insights and just expresses really well the ideas around these validating bridges. For example, this optimistic fraud proof system I was talking about. It's a great read, I suggest to you all. And Infura has been live for a number of months now. I believe since July, Infura has been running nodes on Arbitrum and providing RPC endpoints for developers to use. And it's been great. Developers are able to continue with the stack they're comfortable with. They can use Truffle, Infura, whatever they want, plug and play. They just put this new RPC link, this new Infura RPC API link that points now to Arbitrum instead of Ethereum. They're able to deploy their contracts, and they just are able to save gas that way that easily. And yeah, there's this big question of, we've shipped all this tech, but what's coming next? How are we improving? How are we adding another zero, right? And we've got Arbitrum Nitro around the corner, which is our next gen tech, which we're switching out to the virtual machine that we actually proved back to Ethereum. We're going from the Arbitrum virtual machine to WASM, and we're changing the proving code, which is what actually runs in this VM. And we're switching it to run with Geth. And by running Geth, we're able to inherit this code base from Ethereum that is a mature code base with many eyes and many people contributing to it. And we've also, like in the time we've been developing Nitro, we've been able to upstream some fixes that we found ourselves and contributes to the Ethereum ecosystem. But yeah, there's this next gen coming out, And we got a lot of the question of like, oh, if Nitro is coming out, should we wait? Should we not deploy on the current like Arbitrum chain because there will be this new one? And the answer is no. Just deploy now and start enjoying the savings, because there will be no migration needed. It will be a seamless upgrade. And yeah, so Nitro is this big thing, and other big things on the roadmap that are coming include ETH2. The data availability shards coming along with ETH2 will drastically reduce the costs on rollups, including Arbitrum, and also Arbitrum channels. That is this idea of how can we design a protocol if we start relaxing this idea of like the data availability guarantees, and the savings there are pretty amazing, and different use cases can benefit a lot from this trust model from Arbitrum channels. Yeah, if you want to learn more, we have tons of material online. We have a set of tutorials. We have a blog where we do some more long text around some of the ideas, and we have developer documentation where you can read about how to get started or some deeper rationale around how the protocol works. And yeah, we're also hiring. Feel free to apply. And yeah, thank you very much. And I think we have some time for a quick Q&A, right?
Yeah. Absolutely. Thank you so much, Fred. Yeah, we do have quite a few questions for you. Go ahead and leave your screen share up
Sure.
if you don't mind, Fred. And that way we can kind of leave those links for people. By the way, we're going to share all the links that we're sharing in this presentation today with you guys after the call, so don't worry. Also, in case you can't find them on Discord, we'll definitely give you the links that Fred just mentioned, and Chris will probably have some links too. So yeah, Fred, why is the sequencer? Actually, I know that Nick had answered this in the comments. Thank you, but we'll see. We'll throw this up here anyway. Why is the sequencer necessary? And doesn't L1 order transactions
So
sequentially?
yeah, the sequencer isn't necessary for the protocol. You see that if you go through our documentation, there is a lot of what we talk about how Arbitrum works with the sequencer and without the sequencer. And it's kind of like a plugin that you can put if you want this idea of the soft confirmations. And what it does is exactly what I said before. That is, if you were willing to trust it and its soft confirmations, it allows you to have a very quick UX to just like, for example, you're going to mint an NFT. You get either the revert or the mint like in a question of like 1 or 2 seconds. And for users, that makes a very big difference. But if you're having a use case where you don't want to trust the sequencer because of the amount of money you're going through or just because of your temperament, then you can always just ignore it. And instead of trusting its fast confirmation, you can wait until it actually posts something on chain, until it commits to it. And then the rest of the protocol works the same in the sense that there's the proving system that people can see that it wasn't included. And yeah, that's how it fits into the trust model, I'd say.
Great. And we do have another one. Why do we need to use, we lost that there. Okay. So it basically says, we do have this answered as well, but you can answer. Will Arbitrum be available on 1inch?
So I believe there was an initial deployment of 1inch. It was live, and I think they had a few technical issues, and we are working through them and should be live again soon.
Okay, great. And again, all the documentation. Can you move one slide back, Fred? I think you had a couple more links on there. And then thank you, May, on the chat. She's posting some great resources for you guys as we're going through all this stuff. Also, we do have a question. Why do we need to use more gas when we deploy contracts on Arbitrum?
So when you're using a rollup, there's this notion of the data being available on chain. And what this means is all the inputs to the transaction are actually posted on L1 Ethereum. So whenever you're using a rollup, whichever rollup it is, and you're deploying a contract, the bytes code to this contract is part of this inputs to the transaction. So when you're doing the deployment, then all this data is actually included on the L1, and sometimes contracts are quite big, and that drives the cost up. But yeah, as I was saying before, we have other products that play around with this notion of data availability, not play around, but do relaxations on this guarantee for the protocol. And if you're willing to like not have all the data available on chain for your use case, then the contract deployments are quite cheap.
Awesome. All right. Well, we're going to move on to Nick. Thank you so much, Fred, for your information. Some questions we still have in the queue, but don't worry. We'll get back to those. If we don't get them at the end of this call, we'll go ahead and answer those on Discord for you later. But let's go ahead and pull Nick up. We'll go ahead and end that share, but thank you again, Fred. And Nick, we'll go ahead and you can share your screen. And this is Nick from Truffle. He is head engineer for Truffle. I actually had the pleasure of working with him directly way back when I was with Truffle, and now we're together again at ConsenSys. So I'm very excited to hear Nick's updates.
Hi, everyone. Yeah, I'm Nick. I lead the technical and product direction for Truffle. Firstly, thanks, Infura, for having me, and congratulations on the 350,000 users. I'm here today to demo something that I think is really cool that we'll be releasing soon. But first, for those of you that are not familiar, the Truffle suite of tools is mostly these two tools. There's Ganache, which is our blockchain simulator. It has a development focus, and that means that it gives you nice features like zero config mainnet forking. You can unlock arbitrary accounts. You can rewind time, that sort of thing. It's very useful for a lot of different use cases when working with Ethereum and other blockchain technologies. Truffle kind of sits on top of that, alongside it, and it's this workflow first tool that lets you write your smart contracts, compile them, debug them. We have a fully featured Solidity debugger, an automated test framework. But I'm not here to talk about these two specifically today. I'm here to talk about a problem, which is that if you're building a dapp, you probably need to share your private key with someone else's JavaScript. Have any of you ever had to do something like this? It's like I had to pixelate those secrets because I wasn't comfortable sharing those secrets with you all, 364 of my close friends. You think I want to share that information with JavaScript? Node.js. I don't. Absolutely not. Okay, I know what you're thinking, but isn't it MetaMask's job to keep all my secrets safe and do my signing for me? Yes, it is. It is MetaMask's job. MetaMask does that very well, and I love MetaMask. MetaMask is incredible. It's like basically invented Web3 or brought Web3 to adoption. It's like holds all my secrets. I can hook up a hardware wallet. I can interact with dapps, and it all works great in a web browser. But I'm often doing like smart contract development from the terminal. How do I get to use MetaMask from the terminal? Okay, all right. So we're working on it. We have Truffle dashboard, and that will allow you to deploy your smart contracts. You can like pause, unpause from an interactive console. You can switch networks from testnet to mainnet and so on. And you can use MetaMask. Yeah, pretty cool. So for the demo today, I just want to set up what I'll be demoing and then how I'll be demoing it. So I built this demo application that's a guest book because I like to show off I'm doing off-chain signatures with EIP 712. And that means that you can sign a message but not submit it. You can sign a message with zero Ether, and someone else can submit that on-chain to sign the guest book. You can look at the repo there. The course of the demo, I'm going to deploy the contract. I'm going to sign an off-chain message from an account with zero Ether. I'm going to then switch accounts, submit the transaction, and then we'll make sure it worked. So let's try it. I have a different browser profile. This is just set up with MetaMask on Kovan with an Ether. With an account, I've got like 9.9 Ether. So first things first, let's do this. I'm going to run Truffle dashboard. And this is going to pop up. I'm going to do the familiar connect wallet flow. I have two accounts here. I already gave the permission, so it skipped that. But you can see Truffle dashboard asks for confirmation so that I don't accidentally deploy this guest book to mainnet. So I'll just confirm that. And the dashboard is all set up, ready to go. We don't need this window anymore, so I'm going to minimize it. I'll also resize some things so that you can follow along. What next? Let's do this. Let's do Truffle migrate. Oh, one more thing actually before I dismiss this. Notice that all Truffle dashboard is really doing is it's giving you this JSON RPC URL. And I mean, of course, I'm going to demo this with Truffle, but you can use this with Hardhat. You can use it with Brownie. You can use it with Ethers, dapp tools, whatever. It's just a JSON RPC, and it will capture all your requests, and it will relay them through the dashboard. And well, you'll see. So back to minimizing this. I'm going to run Truffle migrate, and it's going to start deploying. Here we go. So Truffle migrate has told the dashboard, hey, we need to send a transaction. We're deploying a contract. So the dashboard displays it to the user, to me, and I can choose if I want to process that. And you can see I use the MetaMask confirmation window that I'm familiar with. It tells me it's a contract deployment. It's going to cost some money, and I can confirm. And now we're waiting for confirmations. Cool, that worked. Now let's try it out. So Truffle has an interactive REPL. We call it like Truffle console, read eval print loop. And this lets us interact with our live contracts. So let me grab that. We have our live guest book. And for this project, because EIP 712 signatures are kind of complicated, I just made a module for a bunch of utilities that I'll be demonstrating. So I give it the guest book. And let's start by just seeing who has signed the guest book already. No one has signed the guest book yet. Great. All right. Now let's switch to an account with 0 Ether, because I'm making claims that I want you to believe. Yeah, Jacqueline, it's a new keyboard, and I'm having a lot of trouble getting used to it. Anyway, let's do this. We're going to sign a message. Hello, Infura community. So that's what I'm going to do to sign it, but I want to capture it to a variable. So I'm going to say const signed message. And that's a promise, so I'm going to have to await it. Cool. All right. Now you can see that we have like the Truffle console, this utils.sign has asked Truffle dashboard, hey, could you please sign this message for me? And the dashboard displays it. It's a 712 signature, so it's structured so we can see what it is that we are signing. And I'll just process this. It's from this account. This is account 2 with 0 Ether. And I'll sign that. And you can see that we have the signature here. Now let's switch back to the account with Ether, and we'll submit it on chain. So dismiss that. And now we'll just do utils.submit, signed message. And as previously, the console is asking the dashboard, sign this for me. And we will do just that. Kovan is processing. Great. All right. Shall we see if it worked? How about that? I guess it worked. All right. Well, thanks, MetaMask Fox. I'm glad you enjoy it. Anyway, what to expect. This feature is almost done. We've got some finishing touches. Most of what you see will be the same as what we release. But after that, we're really excited. We have a lot of cool ideas for Truffle dashboard. I mean, Truffle's been stuck in the terminal, which has very little screen real estate, and suddenly we have a web page. So we're thinking things like context clues, like maybe you have 10 contracts in your application and you have to deploy them one after the next. So we could show you where you are in the deployment and show you like what step you're on and stuff like that, and spinners and things. Very exciting. You probably noticed there was a lot of hexadecimal on screen. We have our own decoding library. We want to show decoded values. And like kind of perhaps our most ambitious goal. So we have our Solidity debugging library, and we have our command line interface for that. But, you know, we really could use Truffle Dashboard as a place to do like one-click debugging. Like you are about to send a transaction, and you just click on the debug button, and you can step through it and see what's going to happen. So yeah, really exciting stuff. So the Truffle Dashboard stuff works with Hardhat. You could just use the RPC URL. In fact, like in the course of building Truffle Dashboard, we obviously know that people use Hardhat. So we have test cases to make sure that we support Hardhat, because we think this functionality is extremely useful and we do not want to be exclusive. Anyway, that's all I got for today. Thank you all. Appreciate it.
Thanks, Nick. That was amazing. Love your demos. But that was great. And if anybody has any last minute questions, if not, and you don't have it queued up, please continue the conversation with Nick. Oh, did we lose him? Don't go away, Nick. Come back. You do have a question. Let me see if I can get him back up on here. In Discord, we have a Truffle channel as well, just like we have him for Infura. And we're going to invite him back in. How he not think he'd have a question? So he kind of answered that. I do think there was kind of a generic
I
question.
just don't know how to use computers. I'm sorry.
It's okay. But yeah, we had a question come in from I forget the username, OX something, you know, anyway. So I'm sorry about your usernames out there. I wish I knew your real names, but it was just about the Truffle versus Hardhat. I think I appreciate that you talked about, you actually have an integration for that rather than saying from a competitive standpoint. But just for everybody to understand, just because I know that is something that bubbles, is what do you think in terms of Truffle, what is an advantage of using Truffle in these kind of transactions versus like Hardhat, for example? And I love that we have an integration as well.
Yeah.
That's playing nicely. Go ahead.
Well,
Nick.
Truffle is really good at keeping a handle on the high level details of your project. So like our decoder is the only decoding library that produces machine readable output. Our debugger supports every Solidity feature. We can even debug Viper experimentally. So like using Truffle Dashboard with Hardhat, I mean, we're going to do what we can to support everything, but I don't know if Hardhat projects will have the information that is necessary to like do some of these features. Like, I mean, Hardhat has like that Hardhat deploy plugin, but that's not going to provide the same information that Truffle Migrate does for instance, that the context clues that I mentioned. I don't know if it's going to be possible for Hardhat to tell Truffle Dashboard how to decode a transaction, things like that. There's like knowledge that Truffle is able to keep just from, you know, being around for a long time by solving these problems for a long time. And so I think you'll see there will be, you know, Truffle Dashboard will be useful anywhere you use it. I firmly believe. I think, but if you use it with Truffle, you're going to get extra features.
Yeah, that makes sense. All right, great. Thanks so much, Nick. And we are going to move on, hand the baton over to Chris from ClubNFT, which he has an awesome headband on representing. All right, so I'll go let you screen share now if you'd like. And
hi, everybody.
take
How
the
are you
mic.
doing? I'm Chris. I'm the CTO and co-founder of ClubNFT. I am thanking my lucky stars that I don't have a demo to give today, because there were a few pretty fantastic ones today, and that would be a pretty hard act to follow. Yeah, I'm just here to talk about a little bit about something that we at ClubNFT and Infura got up to a couple weeks ago. So I don't think that it's necessary to explain to this very technical audience, you know, what are NFTs and how does that whole thing actually work. But it's interesting to note that just earlier last week, somebody got a lot of press for putting up a fake kind of torrent site called the NFT Bay and offering to let everybody download about 18 terabytes worth of NFT media. And for kind of the general public who don't really understand NFTs, they don't really get it, this seemed kind of like a mic drop moment that, oh my God, you can steal all of these NFTs, so what's the point? Whereas, you know, kind of everybody who is familiar with NFTs already knows that the media itself, like, anybody can go see that. You don't need to own the NFT to view these things on marketplaces, and you can, you know, right click save the NFT media. So this wasn't a surprise to anybody, you know, actually in the community, but this, you know, particular stunt got a ton of media attention, just kind of showing that the vast majority of people out there don't really understand it. A couple like interesting points. We looked into it, and the torrent's empty, so it was all kind of a lie. The guy who did all of this, he then went on to release his own NFT and sold that on OpenSea. So it's kind of interesting. We have a little breakdown about this whole event, but more, you know, importantly, just providing some kind of educational resources for the folks who maybe saw this and thought, oh my God, and thought it was a big deal. Just explaining a little bit about NFTs and how they work. Now, this is important. We actually were really hoping that this torrent was real, that there really was 18 terabytes worth of all of the Ethereum and Solana NFTs available for easy download. And we're actually pretty disappointed that it wasn't the case. And that's because people don't really understand that NFT media is typically stored off-chain, and that media is actually somewhat, you know, out of their control. You think that you've bought an NFT, so you own it and you have complete control over that, but you don't realize that, you know, a marketplace, wherever that NFT was actually minted, they're the ones who are kind of behind the scenes paying for storage, for pinning services and so forth. And not every marketplace actually uses the best in class pinning service available. I think that, you know, collectors ought to know where these things are actually living and be able to take control over them so that they can make maybe better decisions. So a case where this actually kind of mattered and started to get a little bit of attention from the broader community who maybe didn't know about this stuff before was a couple weeks ago when Hic et Nunc just shut down without any notice. So Hic et Nunc, very popular Tezos marketplace. And the owner, creator, founder, really one guy with all of the keys to all of the code and services, he got a little frustrated and just decided to shut the whole thing down. So this raised the question of, is he going to continue to pay to pin all of the media for all of the NFTs that were created on his site? All of the NFTs themselves, they're safe, they're on the Tezos blockchain. Other marketplaces popped up immediately as mirrors of Hic et Nunc. But the question about what to do about all of this media was kind of a big deal. So we at ClubNFT, you know, heard about this immediately, and we decided our goal, our mission as a company is to release tools to allow collectors to really take control of their media. Until those tools are ready, it's just a larger goal of the company to keep NFT collectors safe. And the fastest, easiest, most straightforward thing we can do in this case, until our tools are ready, is just offer to pay for all of the hosting pinning costs for all of the Hic et Nunc media. Now, you know, the founder of Hic et Nunc may have been an artist with his own, you know, strange views on things, but he did choose originally to host all of his NFTs media with Infura, which was a good choice. So we were able to reach out to Infura a couple weeks ago and basically just work with them to repin everything under an account that we were going to pay for. This is about 1.5 million IPFS CIDs. Some of them are, you know, directories containing multiple files, so could be tens of millions of files. It was about 4 terabytes of data. It was a pretty significant undertaking, and one that we really wanted to complete within just a few hours, because it's not clear how long some of this data can survive on IPFS if nobody's paying for it. So other folks in the community also stepped up and repinned these things on other services and using other technologies, some Filecoin or Pinata or what have you. But it took them, weeks, or at least, several days to get that all done. By working with Infura, we actually were able to get right in touch with their engineering teams. We set up a task force to take care of this. It was all done, very, very quickly. And, we were happy to be able to provide this service with the community and also, really build a good relationship with Infura, who's been fantastic to partner with. So, this is kind of a nice community thing that ClubNFT and Infura were able to do, but it's really not kind of our longer term solution at ClubNFT. We don't want people to be relying on ClubNFT to continue pinning things or a marketplace to continue pinning things. We want people to be able to make those decisions themselves. So ClubNFT is working to put tools into collectors' hands to do all of this stuff. The first tool will be focused exclusively on the NFT backup and storage solution. So effectively give all of the media in a nice, easy to handle way to the collectors. It can actually be kind of difficult, first of all, to find all of the media associated with each NFT. Some NFTs are pretty non-standard. And as well, some NFTs point to media, which on IPFS, which then is also a JSON blob pointing to other media, and it can go out into a pretty big web of files that you actually have to track down to make sure you don't lose your data. So doing all of that work for them, giving them the files, giving them the metadata necessary so that they could repin this to IPFS. That includes pretty much all of the IPFS command line options, some of which are built into the CID associated with the file, and some of which are not. So you can actually get a different hash for the same file depending on some options that you use when you pin things. So giving them all of this information, and once they have that, then they can choose very easily to go with a world-class storage provider like Infura, or maybe they just want to burn it to a CD and stick it in a bank vault. There are a lot of ways that people can secure their media. We think that it should be up to the collector, because just relying on marketplaces has been shown to be a little dangerous. It's not a great long-term solution. We're all for any solutions where marketplaces are trying to do things better. Some of them pin with multiple services. Some of them have big backups on Amazon S3. We've spoken with a lot of marketplaces about what they do. And this problem really keeps them up at night, because they know that as soon as they lose some of this data, they're going to piss off their users, and that's not good for anybody. The really long-term solution is to put that responsibility and also the tools into the collector's hands to do this themselves. So that's why we're here. We were happy to partner with Infura, and we're happy partnering with them going forward as we look into integrations for our tool to make things easier. But yeah, it was just a fun little side project that we were able to do, and we really appreciate Infura helping us out on that. So if you're interested in learning a little bit about what we do and how we do it and why this all matters, I believe that we'll be making these slides available for free. I can also post some of these things in the chat. And yeah, thanks from everyone at ClubNFT, and thank you all for having me here to talk about this. It's a real pleasure. Thanks.
Thank you, Chris. Can you move? Oh, actually, keep
Sure,
sharing that if you don't mind, and then and you can pop that on the next one. So we're coming up to the hour here, but we do have a few minutes for some last minute questions from all of you guys. And great presentations from everybody. Thank you, Tom, Fred, Chris, and Nick. Can you do one more slide next? Chris, I believe. Thank you. Perfect. All right. So we're leaving you with May is going to stay on the chat because she's like a chat ninja and she's providing you guys all the resources. Of course, these links are going to be available. We're going to send in a follow-up email to all of you who have RSVP'd and attended today. But also you can, we'll be posting this in the Discord community as well. But make sure to follow Infura. Here are all the good links. And of course, everybody here today, Fred with Arbitrum, we have so many great questions, and we'll get to those real quick. Chris and Nick as well at Truffle. So let's see here. We do have a quick question, Chris, since you were just up. I had a question from Scott. He was asking, how does this work? Wouldn't they have to update the NFT URI for this to work?
Yes.
So I'm
So
guessing you know what
the
that means.
trick to this is that if you have all of the original media in the exact form that it was originally uploaded to IPFS, and you have all of the settings that were used when it was uploaded, then if you re-upload it to IPFS yourself at a later date, it will get the exact same hash and effectively unbreak that link that was stored in the token. So effectively, our goal is to make sure that you don't have to go in and try to like change the contract or change the token URI. Those should be immutable, and you should just be able to restore the data yourself. If you don't mind, I also see a question from Miyamoto in the chat, if I could answer that real quick.
Yeah, go for it. Go for it.
We think that actually it already is the responsibility of the collector. They just don't really know it. So if you were going to say, buy a Van Gogh for, $100 million and you were to put it up in a museum, would you just rely on whatever insurance policy the museum has if in case it, burns down or something? Presumably, you would do your best to take out insurance on something that matters to you, cost you a lot of money, and that you care about. We don't think that, we're trying to relieve marketplaces of their responsibility to pin the content and make sure that it doesn't disappear. We just think that the nature of the world is that data losses happen, marketplaces go out of business, things happen, and we'd like it to be an option for collectors to be able to take control into their own hands and take further steps to ensure that their investments don't disappear.
Thank you, Chris. Yeah. And we have, let's see here. We have a question for Fred. This is coming in from Ab Y. It seems that Arbitrum will increase the entry of legal currency. Please, when can you add this function? Just wondering if this is something that you guys are working on. Does that make sense, that question?
Yeah, so I commented there asking for them to clarify
Oh,
what do you
you
mean by
did.
legal currency and why we will make it easier entry.
Gotcha. Okay.
Yeah.
Let me just see here.
Maybe it's a
Maybe it's
terminology
terminology. Yeah.
issue.
Can you answer that on the chat there, or so we can come back, wrap back onto that? Excuse me. All right. How about transaction fee of Arbitrum is still very expensive. How can we solve this problem? Is this something you guys are working on?
So there are multiple things. First thing I'd say is Nitro. Our next release will be really awesome in that sense, reducing fees and making Arbitrum even more compatible with the EVM. And on top of that, also the data availability shards that are coming with ETH2. Those will drastically reduce costs. And yeah, we've got a set of optimizations in our pipeline that we'll be releasing continuously. So yeah,
Great.
good things
Awesome.
are to come.
And one more, we had quite a few when you were speaking. Do you have any initial designs on the decentralized sequencer? Wonder how a mechanism to support that would look. ZK, incentives, question mark. This is from George Valentin.
Yeah, so anyone who's curious, I dropped in a link there in the comments in our documentation where we actually talk a bit more about this decentralizing fair sequencing. And the approach is based on like greenfield research done by our CEO in collaboration with some other researchers. And it's this idea that before people talked about BFT and achieving consensus on states, but not really the timing guarantees you get around this and fairness of actually the timing of messages going in. And based on that research, there was actually like consensus algorithms with a strict notion of what is like order fairness that came out of it. And I think just last week, a new paper came out as well. And yeah, it's a growing field. And in this doc link, we talk a bit more about it. And yeah, there are quite a few papers out.
Great.
Interested in digging in.
Thank you so much, Fred. Yes, I think we do have a question for Chris, possibly from Darwish. I think he was asking, I don't know if we wanted clarification on that, but do you see that in the chat there, Chris?
Yep.
In terms about, yeah, okay, go ahead.
Yeah, so I think Darwish was asking, why don't people pin their content to IPFS in the first place? And actually, the majority of NFTs, they actually do. This is handled kind of automatically by the marketplace. So yeah, other context, some people on the chain were kind of coming to the realization that, oh, it's probably a bad idea for your NFT's URI, pointing to the media that you care about, to be pointing to something like Amazon S3 or a regular website. That's absolutely true. So if that website goes down, or if the owner of the website just changes that image to a totally different image, suddenly your NFT has changed in a bad way. IPFS is a best practice for hosting the media associated with NFTs, because as long as somebody has a copy of that somewhere, they can always restore the exact same thing to IPFS.
Awesome. Thank you so much, Chris. And I think we are about at the hour. I just realized everybody's a little unmuting you guys. Thank you so much, everyone, for joining this community call. I did want to just kind of quickly on the polls that we got. Thank you for answering this. It does look like that there's a lot of people who are still discovering Arbitrum. So that's probably why you got so many questions, Fred. But there are some people who have some experience. That's great. We'll continue to kind of explore that. And again, please continue the conversation with everybody with all the contact. We'll send this out again. The slide deck will share that. So you'll have the contact for Chris and Fred and Nick, and of course, Tom and Nick are in our Discord community already. So please join us there with any follow-ups. As May mentioned, you get a free forever trial. Check that out on infura.io/register. And of course, follow us on Twitter. But thank you again. This will be available for replay at the exact same link, which is really nice and convenient. You'll get a follow-up email with all this good stuff too. And we hope to see everybody at the next community call. In fact, there's probably going to be a really cool surprise, holiday surprise. So you won't want to miss it. All right. Well, thank you, everybody. And have a great holiday. Yes. Thank you. All right. Bye, everyone.
Thanks, everybody.